Okay, so obviously in today's lesson we'll be looking at trigonometry. So this is everything that we need to cover, not necessarily all in today's lesson, but we'll see how far we can go. But one thing for sure, this is just an introduction to trigonometry. So we just have to make sure that in terms of all of this, we are all on the same page. So I just want to make sure that even though you are preparing to write for next week, but let's rather focus on having a quality lesson and not skip some other stuff. Because what happens is that in the future, when we do upcoming lessons, if we jump some of the other stuff, it might be complicated for you to understand a upcoming lesson. So let's just make sure that we move at a normal pace and we follow the correct procedure, or we go through the correct path. So all of this, I think, let me not remove all of this. So we'll just use it as reference. So you, under Unit 1, we'll have a quick chat regarding right-angled triangle. Unit 2, we look at definitions of trigonometry, of trig ratios, trigonometric ratios. Under Unit 3, we look at special triangles. Under Unit 4, using your calculator. Then under Unit 5, solving trig equations. Unit 6, extending ratios to 0 degrees, where angle is between 0 degrees and 360 degrees. So trigonometry, it's a very, very big chapter on its own, LB. So I think we won't finish during this week. I'm pretty much sure that it will take us some few weeks until we conclude, especially that we'll only be doing these kind of lessons over the weekend. So it doesn't necessarily mean that in terms of time, there's a specific time at which we should be done. We have to make sure that we work out this chapter until you are confident enough. One thing for sure, not necessarily preparing you for next week tests, but let's prepare either for your mid-year or your final examinations. So what I like is that it's not like you're completely blank with this chapter. I'm sure you've done some stuff. It's just to browse through so that when we go to the main course, we are all on the same page. So now let's start with Unit 1, where we focus on right-angled triangle. So let me just bring this. Before I continue, you said everything is clear on your side, ne? You're able to clearly hear me, and again, you can easily see over there, isn't it?
Yes, sir.
Okay, so remember, in case if you want to ask something, you can just stop me, then go for your question. So trigonometry, it's a Greek word on its own. It's a Greek word where I think trigono or something between this letter, it represents a triangle, and the other part of this word refers to a measure. So in short, when we are dealing with trigonometry, we actually measure or study the relationship between sides and angles. So going forward, I'll be talking mostly about sides and angles. So this is what trigonometry is all about, of which these sides can be drawn as a triangle, which is a right-angled triangle, or otherwise these sides may be drawn on a Cartesian plane, where we have something similar to that, forming a right angled triangle. So just make sure that at all times when we talk about trigonometry, sides must be involved, angles must be involved. So in short, we measure or study the relationship between sides and angles. Obviously, we are studying three sides, and again, we are studying three angles. Why is it three sides and three angles? It's because in trigonometry, we focus on a right angled triangle. So we have one side, two sides, three sides. We have angle 1, angle 2, angle 3. So something which is special about this angle is that it's a right angled triangle. So for a triangle to be right angled triangle, it means this line is perpendicular to that line, forming a 90-degree angle there. So these two angles may not be known, of which is something we can calculate. So that means we have a side, we have a side, we have a side, which is three sides. We have angle, we know one angle is 90 degrees. So in most cases, we'll be talking about a right angled triangle where we involve three sides and three angles. So let's try to represent that right angled triangle on a Cartesian plane. What is a Cartesian plane? A Cartesian plane is a horizontal line which has got the x-axis and the y-axis. Obviously, you do know very well that we've got quadrant number 1, we've got quadrant number 2, we've got quadrant number 3, we've got quadrant number 4. And most importantly, this is where our zero angle is. Then we've got 90 degrees, 180 degrees, 270 degrees, 360 degrees. So again, before we even go deep, we know very well that we've got what we call a cast diagram. But for now, let's not talk about cast diagram because it's not really what I want us to focus on. I want us to focus on a right angled triangle drawn on a Cartesian plane. We know that point is the origin. So we can draw our right angled triangle in the first quadrant. So this line, we call it a terminal side. So don't worry that much in terms of what is a terminal side or whatever. But this is what we call a terminal side, and then we've got an angle which we call inclination angle formed. And again, most importantly, inclination angle is measured in an anti-clockwise direction. Obviously, you know this is clockwise
Sir, can't hear
direction.
you properly.
Was it breaking? How is it now? Is it still breaking?
It's fine now.
It's fine now, ne? Okay, so what I was explaining is this is a clockwise direction. The opposite of clockwise is anti-clockwise, which is in that direction. So the angle that we are measuring is in an anti-clockwise direction. So this angle, it is called inclination angle. Let me just get a different marker there. So remember, LB, what I'm doing now is just to take you through an introduction that you don't need to stick everything to your mind. So inclination angle. So that angle could be called theta, beta, alpha, or they can use a letter to represent that angle. So I said this one is called terminal side. So something that you also need to be aware of is that in a right angled triangle, each side has a specific name. So obviously, this is that right-angled triangle on a Cartesian plane. So again, to represent a right-angled triangle in the second quadrant, obviously, you are going to have something similar to that. To represent it in that quadrant, you are going to have something similar to that. To represent that in the fourth quadrant, you are going to have something similar to that. So what I wanted to explain is that in a right angled triangle, each side has a specific name. We know that very well. So let me just try to draw this right angled triangle there and say, what are those names of the sides? We know we've got, let's say, hypotenuse. We have hypotenuse, we have adjacent, and we have opposite. And of course, we expected three names because we are dealing with a triangle which has got three sides, and most importantly, which has got three angles. So in a triangle, a right angle triangle similar to this one, LB, you know very well that this side, which is opposite to the 90 degree, is what we call hypotenuse. That we know. So you still have these two sides, and one of these sides, one of these two sides is what we call adjacent. One of these two sides is what we call opposite. Which one, LB, is adjacent and which one is opposite?
The one below is the adjacent and the other one is the opposite.
So in this case, LB, never, ever, ever, ever tell which one is adjacent and which one is opposite if you do not know what is the reference angle. So what I mean by that is, before you can tell which one is adjacent and which one is opposite, you must say adjacent to which angle. Does it make sense?
Yes, sir.
So it's more like you already know this is 90 degrees. So the moment you know where is 90 degree, then hypotenuse is opposite to the 90 degree angle. But in terms of the side being called adjacent and opposite, that's if I say for angle theta there. Can you see? If I put an angle there, can you see now this is no longer you adjacent?
Yeah, it's going to be the opposite.
100%, which means adjacent is always next to the angle. So the side which we call adjacent is the one which is next to the angle. So let's say I've got A, B, and C. Which side is next to the angle?
AB.
Side AB. And BC is opposite. Opposite to what? Opposite to the angle. So that means in a right angled triangle, the moment they say this is a right angle, which is 90 degree, then it means automatically this is your hypotenuse. Then you can't talk further because that's all that you know. The moment they say the angle is there, LB, and no longer there, and they say which one is adjacent, you know very well that adjacent is next to the angle. That means this is your adjacent. Why is it adjacent? Because it's the side which is next to the angle. So this side is the side which is opposite to that angle. That is why we call it opposite. Does it make perfect sense now?
Yeah, yes, sir.
So that means at all times, before you can decide on the side to say this one is opposite or adjacent, you must firstly know a where is the reference angle? So I'm just checking here in terms of unit 2. So what we discussed just now, LB, it was all that we had to talk about with regards to a right angled triangle. Sorry, so I'm going to remove. So can I remove all of this? You don't have any question there?
Yes, sir.
Okay, so I'm going to remove all of this. So I'm glad you noticed that for you to decide on a side, to say this side is whatever, you must firstly be aware of which angle are we talking about. So now let's try to discuss unit 2. But before I even do that, if I draw something similar to this LB and say I've got A, B, and C. Here comes a question. Which side is adjacent?
I can't decide which one is the adjacent because there's no reference angle.
Okay, which one is hypotenuse?
It's AC because it's the longer side.
Okay, so I'm glad you also gave that with a reason. But now, in a triangle similar to this LB, which side is adjacent? Which side is opposite there? This one.
None, because it's an equilateral triangle and there's no reference angle. Plus, it's not a
And
90-degree angle.
okay, all of that you said, does it apply in terms of if I ask you which side is hypotenuse?
Yes, because it's not a 90-degree triangle.
Okay, who said this one is a 90-degree triangle?
So, because, okay, for example, the triangle below has
Mm.
equal sides, then it's an equilateral triangle.
Mm-hmm.
And then the one on top, it looks like a 90-degree angle.
Yes, I wanted you to mention that word to say it looks like a 90 or a right angled triangle. So just like I explained to you to say, you cannot tell which side is adjacent and which side is opposite. Same response applies here, LB. If I did not mention that this is a right angled triangle, you cannot assume based on the fact that it looks like. And again, if I did not draw that sign to show that it's a right angled triangle, we do not assume. So it's either the statement must mention or tell if it's a right angled triangle, or they can say these two lines are perpendicular to each other, or otherwise they can use that sign to show that it's a right angled triangle. So do you agree that this angle can be 80 it can be 89 degrees? That is why it looks like it's a 90 degree angle there. So if it's 89, it's no longer a right angled triangle. Does it make sense, LB?
Yes, it does.
Yes. So that means a no assumptions based on the triangle looking like it's a 90-degree angle, unless it was mentioned that it's a right angled triangle. So that means if I draw something that looks like that, LB, never ever ever assume this is a 90-degree or right angle triangle because it looks like that is 90 degree, unless it is mentioned or unless I did that. So if it looks like this, just assume for it to be just a triangle. Can we agree on that one?
Yes, sir.
100%. So in trigonometry, we only focus on a right angled triangle. So a trigonometry is special in a sense that it only focuses on a right angled triangle and not on just a triangle, but it must be mentioned that is a right angled triangle. So let's now move to a unit 2. So remember, what we're doing, LB, is just an introduction so that when we get to some deep or complicated stuff, we are all on the same page with all of this. Can you see? Because I've just noticed that you discovered some additional info regarding a right-angled triangle. Let's try to talk about definitions of trig ratios. Maybe you might also discover something new there. So let's see. We now discuss unit number 2. So LB, in trigonometry, ratio between sides are given certain names. Let me see. In trigonometry, ratios between sides are given certain names. So let me just draw a right angle triangle. And remember, LB, all of this, you don't need to stick it in your head. It's just for you to be aware of this information. So obviously, as you practice some more and more, that's when it's going to make some sense. So even if you're not writing some notes there, it's fine. This lesson is being recorded and I'm going to forward it to you via inbox. So in triangle A, B, and C, with angle A, let me do this, LB. This is what we call triangle. Obviously, you know. So when we say in triangle A, B, and C, then we are referring to a right-angled triangle of A, B, and C. Then when we say B, A, C, and we do that, so we are simply saying in triangle ABC, angle A in that triangle of ABC. I'm not sure if that makes sense, LB, what I'm trying to explain there.
Yes, sir.
Okay, so the reason to that is because you can still have something similar to that where this is maybe D. So the reason why we have to use these letters is to be specific, to say whatever that we talk about, it focuses on that triangle. And when something is written like this, that means we are focusing on angle A in triangle with these corners or those vertices. Therefore, we can say that angle is called alpha. And again, we can now define the ratios with reference to that angle being alpha. So obviously, we know what are the trig ratios. Do you know what are the trig ratios, LB?
Yes, sir.
What are those?
Sine, cos, and tan.
So these are what we call trig ratios. So let's say we have sine, we have cos, we have a tan. These are what we call trig ratios. So we define ratios obviously for sine. We know very well is opposite over what is it, hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over what is it, adjacent over adjacent. So this is a ratio. This is a ratio. So trig ratio. This is a ratio. Remember, a ratio is something over something, or maybe opposite is to hypotenuse. This is what we call a ratio in a different format. So this is also a ratio in a different format. So we normally use this format to represent ratios. So the reason why these ratios can be represented as x and y. It's because on a Cartesian plane, remember we said if we draw it from the first quadrant, for example, the angle formed is from this zero line in an anti-clockwise direction. So can you see that if now this is the angle, this line is what we call the x-axis and this line is what we call the y-axis. So that means this side is what we refer to as the x side, and the vertical one is what we refer to as the y, and obviously that one is the radius. Does it make sense, LB, that part?
Yes, sir.
Okay, so I'm just going to remove all of this. So just make sure that everything that I explain, it makes sense. If it doesn't, make sure that you question so that everything makes sense. I just have to say all of these so that when we go deeper, I can still refer to some of this information. So even if you know already what is sine, what is cos, what is tan, don't worry that much, LB. I'm just making an assumption that you are completely blank, just so that when I want to teach you something, I can remember that we have discussed all of this, and you won't be confused. So that means everything that I say, you must fully understand. And also, it remains my responsibility to make sure that you fully understand. So it also remains your responsibility to practice so that you do not forget. So let's see. Now let's talk about the reciprocals of the three trigonometric ratios. I remember in one of the lessons you mentioned something powerful, so I'll just straight away write that one to say is cosec. I know very well that you do know this very well. So the reciprocal, the word reciprocal, LB, it simply means a 1 over the same thing, 1 over the same thing, 1 over the same thing, which means this is actually a 1 over sine, this is 1 over cos, this is 1 over tan. So if you have, let's say, you have a letter being A, the reciprocal of this thing, LB, is a to the exponent -1. This is the reciprocal. So anything to the exponent 1 is actually the same as 1 over a. I'm not sure if this part makes sense, LB.
Yes, sir, it makes sense.
So which means this thing, it is still the same thing as that. It's the reciprocal, because angle, let's say x to the exponent that, so mathematically we say anything to the exponent -1 is 1 over anything. So that is what we call the reciprocal. So I think for now, I'll just remove all of this, then we move to a table that I want to quickly show you, of which I think it is going to summarize all of this. So it still falls under unit 2. So we have what we call a trig ratio, and again we have what we call reciprocal. Then from there, we can then have conclusion. So trig ratio, we know very well that that's when we talk about sine angle, which is opposite over hypotenuse. So what is the reciprocal of this? We know is cosec angle. And cosec angle, it's more like you write this at the top and this at the bottom. So it's actually hypotenuse over opposite. So you were aware of this one, LP, isn't it?
Yes, sir.
So that means in conclusion, in conclusion, this thing is actually the same as 1 over a sine angle. So it's more like we do not have this thing on a calculator. that is the reason why we have to find another way of writing it using a sign or something which is there on your calculator. So that is why every time when you're given the reciprocal, you try by all means to rewrite it in another form. Same for, let's say, cos angle, we know is adjacent over hypotenuse. So the reciprocal of this is a sec, which is equals to, then we just do the inverse there.
Wait, sir.
Mm-hmm.
Wait, if we're given like a question to calculate the cosec, so we'd just have to take the number and just switch it.
Wait, so you're saying in case if there's a question which says calculate what? A cosec. Yeah,
Yes.
cosec. Mm.
How would we approach that question?
Okay, so it's more like every time when you are given the reciprocal, you want to rewrite it in a form such that you know you've got this on your calculator.
Oh, okay.
So you could be proving, you could be simplifying or whatever, but in your mind, let's say for us to cram it, we want to rewrite it in a different form and not as cosec because we don't have cosec on a calculator. So we write it in its other form, which is this.
Okay, sir.
100%. So now we have cos angle, which is equals to, we know cos is adjacent over hypotenuse. So the reciprocal of this is actually sec. And sec is more like we have the hypotenuse over adjacent. So we just swap the denominator and the numerator. So that means this thing is actually equals to 1 over cos angle. So now let's talk about cot. So cot tan. Tan. We know tan is opposite over adjacent. The reciprocal is cot. What is cot? Then that means cot, we swap those, we have adjacent over what is it? Opposite. Which is the same thing as what is it? 1 over tan angle. So let me explain to you something because I've done this in that way, LB. I've explained to you from tan, we move to reciprocal. From trig ratio, we move to reciprocal. From reciprocal, then is the same thing as that. So let me now take this one to the name. So let's see. When you have 1 over sine angle, so we know that this thing is the same as 1 over a what is it? Opposite over hypotenuse. So this thing where you have 1 over something is the same as 1 divided by opposite over hypotenuse. Do you agree with me on that one, LB?
Yes, sir.
So do you also agree that that sign, we change it to a multiplication and we write that at the top as hypotenuse and this one at the bottom as what is it, as opposite? Do you agree?
Yes, sir.
Which means 1 times all of that is actually hypotenuse over opposite. And we know this thing is actually what is it? Hypotenuse over opposite. We know we have opposite. So is the reciprocal for a sign which makes it a cosec. So it's more like I try to now explain in reverse, but it shouldn't be something which complicates or confuses you. What we have discussed in terms of what a sign is, and again, what is the reciprocal of sign. With these 2 columns, it's enough, because always when you are given that, you can easily prove or simplify or calculate. But if it's given in that format, you now need to rewrite it in that format for you to be able to either simplify, prove, or solve for trig equations. So that's all, LB, that I wanted to discuss with regards to the definition of trig ratios. So let's now move to Unit 3, where we talk about special angles. So let's see. In terms of the special angles, did you also study that in class?
Yes, but then like I didn't quite understand how we got
Okay.
the special angles.
Okay, so for now, let's just discuss special angles. Let's just discuss special angles. So ratios of certain angles are well known, and we can use them to solve problems. And these angles, LB, are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So for this lesson, we'll focus only on 30 degrees, 45 degrees, and 60 degrees. So obviously, angles LB, I mean, angles, yes, are from 0 to 360 degrees. Nay, but within this angle of from 0 to 360 degrees, we have some angles which are special. Just like in a country, LB, first thing first, we are all humans, which means for example, from 0 to 360 degrees, we know we are all humans. But within us as humans, we know we've got, let's say, special people. Who could be those? For example, let's maybe just say the president. Um, can we can just regard the president as a special person? And again, amongst humans, LB, who can also be regarded, let's maybe say the priest, as an example. Who else, LB, can be regarded as a special person?
Let's just say celebrities.
A president, priest, not presidents, but president, just one president, and let's say one priest. Then okay, let's say celebrity. Celebrity, it's fine. So all of this, LB, first thing first, these are humans, but this one is special, this one is special, this one is special. So these are all angles, LB, but this one is a special one, this one is a special one, this one is a special one. But there's nothing interesting about those other than them being humans. It's just that they are special because of certain characters. So a president is a president. We know they represent the country. A priest, we know they speak the word of God. Celebrities, let's just say for entertainment purposes. And then the rest are just humans with common, let's say, common characters. So now we can represent these special angles in a form of a triangle. Let's see. We have a triangle. Let me start with that triangle. I need some space there, or maybe let me just draw it there to say we have one triangle representing one special angle. So this is just a triangle, LB, but the moment I do this, then it's a special angle. Then from there, not necessarily a special angle, but a right angled triangle because of that name. So you cannot tell which side is adjacent, which one is opposite. But the moment I write 45 degrees there, you are able to tell which side is opposite, which side is which side is opposite, which one is adjacent. So there you will always have one, there you will always have one. And when you use theorem of Pythagoras to calculate the hypotenuse, you will get square root of 2. So in short, LB, this triangle, which is a special triangle, it doesn't change. It will forever be like this, even when you get to varsity. So that means always when you have a right angle triangle and that angle is 45 degrees, your adjacent will always be 1. Your opposite will always be 1. Your hypotenuse will always be square root of 2. So this is the special angle for a 45-degree angle. Let's now check for that one of 30 degrees. So still, it's a right angled triangle. The moment I do that, it is a right angled triangle. So now let me have my 30-degree angle there. So the moment, LB, I have my 30-degree angle there, you will always have this side. What is this side? The name of that side.
The opposite.
Opposite will always be 1. Adjacent will always be square root of 3. Hypotenuse will always be 2. So this is a special angle for a 30-degree angle, and it will always be like this. Let's now do the one for 60. Let's see. So we have.
Wait, so how did they get the square root of 3?
So remember, it's okay. So in this case, LB, it's not like they had to maybe do some calculations or whatever. But for the sake of answering your question, you remember that we have r squared, which is equals to what? X squared plus y squared. So if you know this is 1 and this is 2, so that means your hypotenuse is 2 squared, which is equals to a adjacent is what you don't know, so it's x squared plus 1 squared being your opposite. So when you transpose, this is obviously 4, so it's more like it's 4 minus 1, which is equals to x squared. So you have 3 there, which is equals to x squared. So can you see, you now remove by square root, you therefore have x, which is equals to the root of 3. I'm not sure if I've answered your question, even though this triangle is always like this. So for a triangle which has got a 30-degree angle, you always have 1, you always have 2, you always have square root of 3. I'm not sure if it makes sense, LP. It's more like it's a formula.
Yes, that makes sense. Thank you.
Yeah, so can you see that you just need to know that. Let me try to think of something, LP. Let me, maybe in one of some other lessons we'll find out. It's more like a formula maybe which says Tn is equals to a plus into n minus 1 close bracket d. So when you said how did they get square root of 3, it's more like on this formula you are asking me how did they get that one. Does it make sense?
Yes, sir.
Yeah, so it's not necessary to explain because it's just a formula, or it's always like that for arithmetic sequence. So here for a 30-degree, for a right angled triangle with a 30-degree, this is how the sides looks like, and again these are the values for those sides. Let's check this one where you have 60 there. So this one where you have 60 there, LB, is the same thing as this. Also there is the same thing. Does it make sense, LB?
Yes, it does.
So
Just something
this
that
is
you
the
have to know.
formula. So this is the formula for these special angles, or these are the triangles for these special angles. But there's something interesting, LB, with these two. So can you see that angle is there? It has square root of 3, it has 2, and it also have a 1. And this angle there, which is that one there being a 60, it also has 1 on this side, square root of 3 on this side, a 2 on that side. So that is the reason why for a special angle of 30 and 60, they represent it on just one triangle. Then we can just hide this one. Does it make sense?
Yes, sir.
So would you say what you couldn't understand in class, do you now understand, even though I did not understand or I did not know what you did not understand? But do you now understand?
Yes, sir.
Okay, 100%. So that means I think I can now move on to the next part of the lesson, because that's all that I wanted us to discuss with regards to special angles. You just need to know that, for example, if you have, let's say, sine 45 degrees, so you just have to draw that triangle and put in all of those. Then from there, for sine, you know is opposite over a hypotenuse, which means it's 1 over square root of what is it? Over square root of 2. So that means, LB, on your calculator, when you punch sine 45, you must expect that answer. So for cos 45 degrees, let's see, it's adjacent over hypotenuse. You must also expect 1 over the root of 2. When you punch tan 45 degrees, LB, you must expect 1 over 1, which is 1. I'm not sure if it makes sense, LB.
Yes, it does.
100%. So now, what about cos? What about cos 60 degrees? What will be that one?
1 over 2.
What is it, LB?
1 over 2.
1 over 2, because cos is that over that. Okay, what about sine 30 degrees?
1 over 2 as well.
1 over 2. So that means we are now on the same page with regards to special angles, and again on how to use those special angles. So now let's get to unit 4, which is using your calculator. So let's see unit number 4, which is about using your calculator. So let me do that. Okay, so this one, LB, let's maybe explain it in a form of a example, and say if we are given a triangle similar to that. This is maybe, let's say it's P, this is Q, this is R. Let's say maybe this is 4 centimeter, this is 12 centimeter. The question says find that, and again find that. So what does the question want you to calculate or find, LB?
To find the length.
Which length?
PQ.
Okay, so let me explain something. So, always in trigonometry, when we talk about the length, always the length is represented by two letters. Why two letters? Because a length is from one point to another, which means if they want you to calculate a length, they are going to use capital letters to say maybe PQ. So the moment in trigonometry they write something in capital letters, you know they talk about the length. Otherwise, they can say the length of QR. Because it's in capital letters, it means it's a length. But the moment they do that and they write P, this is angle, and this is angle at point P. Make sense?
Oh, yes, sir.
100%. So just make sure that you are careful of those. And again, sometimes they don't need to say a length PQ. They just say determine PQ. But because you know it's in capital letters, it means they're talking about the length. Now they want you to calculate the angles. So that means it is that angle and again that angle. So always, because you know you are dealing with a right angled triangle, LB, make sure that your right angled triangle is complete in terms of the sides. So can you see we have that, but this is missing. So how can we find this before we even start with our questions there?
Pythagoras.
The theorem of Pythagoras. So that means we have, let's say, obviously it's 12 squared, which is equals to then it's going to be PQ squared, let's say, plus 4 squared. So what will PQ be? Let's see. We must be having 12 squared minus 4 squared, which is equals to that. Square root of answer, it seems to be. Are you also getting 8 square root of 2?
8, yeah, 8 root 2.
Okay. 8 square root of 2. So it's that side. Then, because now we have 3 sides, it means we can be able to find the angles. So again, LB, in trigonometry, because we are dealing with 3 sides, so that means for you to calculate the unknown side, you must know 2 things. For you to calculate the angle, you must know 2 things. If you know more than 2, then it's a bonus. An extra, it's a bonus. So what I wanted to say is, if we have a triangle similar to that, and we have this side and we have that side, that means with this information, we can calculate everything about that. So that means we have 2 sides. We can use the 2 sides to calculate the unknown side. And again, in a triangle, a right angle triangle similar to that, if we know maybe this is 34 degrees, how many angles do we know there?
2 angles.
So if we know 2 angles, it means we can know the third angle. So can you see that in trigonometry or in triangle, which is a right angle triangle, because we study 3 angles and 3 sides, if we're dealing with the angles, then you need 2 angles. If we're dealing with the sides, you just need to know 2 sides. But sometimes you might know a side, an angle, and a side. So that means for you to calculate the other thing, you just need to know 2 things. I'm not sure if it makes sense, LB.
Yes, it makes sense.
100%. So can you see that you can now easily find maybe maybe angle of P and angle of R. You do know how to calculate those, isn't it? Or do you want me to take you through?
Yeah, take me through with it. I know the angle has to be equals to 180.
Say that again, LB.
I mean, like, if we have like two angles, we can make it equal to 180 or something. I don't know.
Yes, in terms of the angles, you're talking about the angle, ne?
Yes.
Yes, no, you're right on that one. So, but now, in this case, we don't know two angles. We just have one angle. So can you see? We can use this side to make some calculations. So let's see. We know trig ratios. We know we've got sine angle. We have cos angle. We have tan angle. Because you have all the sides, you can choose any trig ratio that you like. For example, if we want to try and calculate angle P, so that means this is the angle that we are calculating there, which is angle P. So if you use sine, that means you are going to have sine angle P. We know sine is equals to opposite over hypotenuse. So according to this triangle, while focusing at that angle at P, what is opposite?
4 centimeter.
So it's 4 centimeter over
12 centimeter.
over 12 centimeters. So it's more like you now have sine of angle P being equals to 4 over 12. So you were saying centimeter, centimeter. So those two units are going to cancel. And now you can remove that sign. Do you know how to remove that sign?
No.
You don't know,
Using
ne?
the sign negative one.
Yes. So a is the second function. So we call it the second function. So that is how you remove a trig ratio from an angle. So that is how you remove it. So a second function of what is it? Second function of whatever that is on the right, which is 4 over 12, which is going to be equals to, then you punch this on a calculator. But remember to make sure that a calculator is in degree mode. So what is that, LB?
19,47.
What is it?
19,4719.
19 that 19 47 degrees. Okay, it's fine. Let's say that angle is 19 47 degrees. So calculate triangle R using a any trig ratio but not sine. Maybe let's use cos. Use cos to calculate a angle R. So remember, LB, there you can just explain by telling me what to write.
Wait, are we doing the same method, or we're going to say 90 plus 90,7 equals to 180? Then we take the 90,7 to the other side.
No, you can still use that method, but here I want you to use a trig ratio to get that angle, not that one of
Oh yeah, I was
180.
just calculating it right now.
Mm.
So sorry,
Are you still?
I was saying cos negative 1, cos to the power negative 1, open bracket 8 through 2, over 12, close bracket.
8 root 2 over 12, that, so you're saying it's going to be angle R. So let's see. You're saying cos adjacent over
hypotenuse.
So you're saying like this, ne? What is the angle?
19,47. It's 19,47.
47. So can you see a LB? It's more like you are now saying that angle R is actually that, which is completely incorrect, because this is the one which is 19,47. So I just noticed something, LB. The moment the question says angle R, that means in this triangle, you forget completely about the other angle. Then you put that there. This is the angle that you are calculating, of which you can call it angle R, or you can say theta, or whatever. So now you then need to use a trig ratio referencing to this angle where we are focusing at that angle there, not that one there, because what you calculated, you still calculated angle P using this trig ratio. I'm not sure if it makes sense, LB.
Oh, okay. I see where I went wrong.
Yes. So, what is angle R?
I'm going to use 10.
No, you can use any. You can use cos, you can use that, you can use that. Or maybe, no, let's use sine. Let's use sine.
It's going to be 8 square root 2 over 4.
Okay, let's start it as sine R being equals to what?
Sine -1.
No. For now, let's formulate. Let's formulate, because I know once we formulate, you'll get it right. So for now, let's formulate using sine. Yeah.
Opposite over hypotenuse.
Mm-hmm.
Then we're going to say it's 8 root 2. Oh, wait, no. The opposite is 8 square root 2 over 12.
Okay. You have correctly formulated it. So let's use that. So obviously you're going to get the second function of that to get that angle. So let's use cos now.
Oh, should I use cos?
Yes, so now formulate using cos.
It's going to be adjacent over hypotenuse. So it's going to be 4 centimeter over 12.
4 centimeter over 12. Okay, so I'm now confident that you can be able to calculate the angles and the sides. So I'll just now remove all of this. So that's an exercise that I actually wanted to take you through, to say that is how you solve. So let's say, for example, let's see, let me just quickly try to check something. Just hold on, LB. I just want to quickly check if I can get something there, because we are still on using calculator. Okay, it's fine. I just want to quickly check if I can get something here. Okay, so let me just write this tan angle being equals to 3,17, 3 sine x plus 1 is equals to 2, 1 over 4 sec angle is equals to 5. Okay, so let me now go back to where we were. So what were we discussing, LB? Where were we? Let me see.
We were doing that little exercise for using the calculator, calculating the angles.
Oh yes, using a calculator. Okay, so that means we are done with that part of using a calculator. So that's all that I wanted us to discuss on that one. So now we are moving to what is it? Solving trig equations. Let's move to that one and let's see. These are the trig equations that I want us to solve. Did you attend that lesson where I was explaining what is an equation, what is an expression? Were you there? I think it was yesterday's lesson.
Yes.
Okay, so now under unit 5, we are solving a trig equations. So we said an equation can be noticed the moment we have an equal sign between terms on the left side and terms on the right side. So now on the right side, we have maybe something like tan angle, which can be equated to 3,17. Sometimes you might have x plus 2 being equated to, let's say, 4. So are both of these LB equations? Are both of those equations, and why?
Yes. Because they both have equal signs.
Because they
One to
both
the
have
left and
equal
one to the
signs.
right. Yeah.
But now, what type of an equation is this? Do you know?
Linear.
100%. It's a linear equation. So if we had 2 there, what type of an equation would it be?
A quadratic equation.
A quadratic equation. So something like y maybe minus 1 less than 0. What type of a problem is this?
Is it inequality?
So we say it's a linear inequality. So the moment we put a square over there, it's going to be a quadratic inequality. Nay.
Yes, sir.
So this one, what type of an equation is that one?
Trig equation.
100%. So this is what we call a trig equation. What makes it to be a trig equation?
Because it has one of the trig ratios.
100%. So that means we should not be scared about that tan. We just follow the same procedure we would follow when we're solving, for example, this linear equation or linear inequality. So because also this one, it does not have a square, in our mind, at the back of our mind, let's just assume it to be a linear trig equation. Nay.
Yes, sir.
So how would you solve this one, LB? Let's say you're given that equation. How can you solve it?
I'll take 2 to the other side, so it's going to be x is equals to 4 minus 2. Oh, it's another question.
No, you are there. Then continue.
Then it's gonna be 3x is equals to 2. Then I'm going to divide x by 3 and the left side by 3.
Okay, 100%. I'm happy now. So how do we solve this trig ratio? Following the same procedure there.
We take tan to the other side, so it's going to be x is equals to tan negative 1 open bracket 3,17.
100%. So let's now work out this one. So okay, let me explain to you this thing. Do you agree that in other words, it's more like we have to divide by tan so that it cancels, and we also divide by tan?
Yes.
So because it's a trig ratio, we respect it. We do not divide by the trig ratio, but we say second function. So this thing, second function, is the same as 1 over tan. I'm not sure.
Yes.
Yes. So that means if we have a trig ratio, we just need to remove that trig ratio. So let's maybe have a look at this one. How would you solve that one? LB, LB,
Okay,
LB,
I'll
LB, LB.
take I'll take I'll take 1 to the other side.
So that
It's gonna
means
be
we have
3
sine
sine x.
that, 2 minus 1.
Yes.
Mm-hmm.
There's gonna be 3 sine x is equals to 1.
Mm-hmm.
And then I'll divide both sides by 3.
Divide by?
No, wait. I don't know, divide by 3, I guess. But then I'd have to take sine to the other side as well.
You divide by 3 because you want it to cancel.
Yes.
So you just want to get closer to the diamond. So you need to remove everything on that diamond. So let's say this is the diamond. This is the stone. You have some dust there. And again, let's say you have water. So everything attached to the diamond, we have to remove it. But we have to mathematically remove it. So can you see? Makes sense.
So you take sine negative 1 over 3.
Yes. So now you remove that, then you remain with this, then you remove that sign again, you end up having that. So would you say with just that, what I've explained, you will never go wrong with solving a trig equation? Does it make sense?
Yes, it makes sense.
Okay, so let me now test if you can find me this gold. So let me do this and say is equals to 5. LB, I need that gold. Take me through. LB, 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 LB,
Yes,
LB.
wait,
Did you
I'm
run
still
away? Why?
thinking. Okay.
Oh, okay.
Okay, it's 1 over 4 sec theta is equals to 5. Okay. We'd have to divide both sides by 1 over 4.
Okay.
Okay, let me calculate that. Okay, so we get 20, so it's gonna be sec theta is equals to, but then wait, those reciprocal.
No, you are on the right track. You are just simplifying that previous step. You are on the right track.
Yeah, so it's okay, sec theta is equals to 20.
Mm-hmm.
So we're gonna say sine negative 1. 20.
Wait. You're saying what are we going to do there?
It's going to be cos -1 open 20.
Like that. Then you say it's equals to
Theta.
angle theta. Okay.
Yes.
Okay, so let's correct it. Remember, LB, you cannot work it out as sec. You need to convert it to that normal ratio.
Yeah, I
So
was thinking about that. It's confusing.
so when you have sec, when you have cosec, when you have sec, write it in its normal form. What is its normal form?
Sec is cos, so it's, you want the thingy.
The trig ratio. So this is
So it's going to be, okay, cos is adjacent over hypotenuse, but then sec is going to be hypotenuse over adjacent.
Okay, so let me do this, LB. Remember, we are dealing with trig equations, right?
Yes.
So this is not a trig. It is an equation, but it's not really a trigonometric equation because we have a reciprocal there. So we need to convert this to a trig ratio so that we can proceed with our calculation. I'm not sure if it makes sense now. So that means you need to convert this to another form of a trig ratio. So when we are
1 over
solving
cos.
for, yes, so it has to be 1 over cos angle. So can you see you now have a trig ratio there, which is equals to 20. Then you can follow mathematical procedure to calculate my gold. So give me my gold, LB. Or should I continue with it up to the end?
Yeah, so just continue.
So remember, on this side, you have a fraction. Do you remember that when you have a fraction there, you can also fractionalize this one on the right?
Yes, sir.
So that means you did that so that you can cross multiply. When you cross multiply, what are you having? You have 20 cos angle, which is equals to 1. Do you agree?
Yes, sir.
So you can easily solve this one, isn't it?
Yeah, do we divide it by 20?
Yes. So confidently say we divide by 20 on both sides because we want to remove water. Then now let's remove that brick to get to our gold. So that means you have angle being equals to that. Then you can easily get the angle. It's as easy as that. So can you see now, the first two examples were for grade 10 stuff. This one is what you should expect in grade 11. Some more complicated stuff in grade 12. Does it make sense now? LB?
Yes, sir. So it's going to be 87,13.
Yes. So whatever that you're getting there, it is 100%. But should I trust you? Let me check. Assuming that I don't trust you, LB, because you failed to give me my gold. Let me see. 87. Okay. Now, this is what we had to talk about with regards to trig equations. So there'll be some more which we'll be doing. So this is just an introduction, LB. On our next lesson, what we'll be doing is to try and check some exam question papers that we can be solving. So surely that should be what we'll be doing, let's say tomorrow. So let's just make sure that if we cover up to whatever point that we can get to, then from there on our next lesson, we try to solve question papers related to that portion of the work that we covered.
So
What do you think?
can we also
Mm-hmm.
do like the identities, because there is a lot, the general term, all that, it's a lot.
Yeah, so also, so you mean in terms of, course, one thing for sure, identities and proving and reduction formulas and everything, they will form part of this package. So I'm just not sure if you're saying maybe tomorrow we can focus on trying to proving, or what are you suggesting, LP?
Yeah, we can try doing the exam type questions.
Okay. No, then it's fine. As long as we started at the right starting point, we will get to that one. But for today's lesson, I wanted us to be on the same page on something. So let's now discuss this part. Let me see. So the last part is extending ratios, and this part is what takes us to exactly what you're talking about now. But before we can get to that, we must have gone through a discussion where we discuss all of that. And this part, LB, it is going to bring us to the end of our lesson for today, of which in tomorrow's lesson, that's when we'll be doing exactly what you're suggesting, of which I do agree 100%. It does have a lot of max extending
Wait, so when are we
ratios.
going to do physics?
What is physics? Physics. Let's see. We can push tomorrow up to a certain extent and still cover what is it? Physics. So in physics, Kana, you said what are we focusing? Is it this thing of what is it? The vectors and the angles where you have something there. What? Or maybe you'll just send me after this lesson, send me a few of examples which you'd like us to go through, just so that I'm 100% sure I understand which part of physics you want. Ne?
Yeah, so
Okay. So let's say tomorrow we will push, maybe sometime in the morning we can push up to a certain extent, then sometime in the afternoon up to a certain extent. So we'll just see in terms of how far we can go. But for now, let's quickly say under Unit 6, we focus on extending ratios to an angle which is between 0 and 360 degrees. So again, LB, I had to take this direction. I'm going to tell you something of which you might understand now or at a later stage. For someone in your position, for example, if you were preparing for the test that you'll be writing next week, instead of you starting at the starting point or starting where we started, you were going to straight away do those problems related to simplifying, whatever. But can you see, LB, you don't have the basics of all of that. So that is why you can still prepare for the next week test. But come exams after a few months, you still need to go through the same process of studying in a similar manner. But once you start from the basics, it's not easy to get surprised when a question comes. So it's not easy for you not to understand when a teacher mentions something, because you have covered the basics. I'm not sure if you understand what I'm trying to explain, LB. So
yeah,
it's
so
more
it
like
makes sense.
I'm trying to say everything has got a starting point, and starting with simplifying or proving, it wasn't going to be the right starting point. So can you see, up to this far, we have been doing some simple or easy stuff, but I'm sure there are a lot of things which are new, of which you learned, and again, they are now starting to make sense. So that is what I wanted to take you through, just so that when we get to that stage, which you are expecting, we will all be on the same page. So for everything that I'll be saying, I'm going to refer to all that we discussed in today's lesson. So to me, it wouldn't be a surprise when I give you a problem and maybe you fail to sort it out. But when I said you still remember this, if you remember, that's when you'll say, oh yes, this is how we work it out. But if I assumed that your teacher, for example, maybe taught you everything, it wouldn't be the right approach, because obviously there are some things of which I might mention of which they did not cover in class. So I just had to make sure that we just go through the basics. So it's more like we are now on our own lane doing the same thing in a different manner, in a different approach. So I'm glad you do understand that part. So for now, let's conclude with Unit 6. Then from there, we'll do one thing for sure, a few examples on simplifying. So once you are able to simplify, it's easy to prove identities, because proving identities is more like you simplify both sides. So you firstly need to be able to simplify. Okay, so let's check. When you talk about extending angles, obviously we know we have 0 degrees, 90 degrees, 180 degrees, 260 degrees. Then that we have Q1, Q2, Q3, Q4. So an angle which is between a 0 and 360 degree is somewhere along that, or somewhere in one of those quadrants. So we know that it starts from there. Remember, this is that. Let me ask you something, LB. When something is written like this, let's say maybe P less than or is equals to maybe 7 and 4, how do you interpret this thing?
Is it P is less or equal to 4 and 7?
I did not get that. What did you say?
P is less equal to, or do we say 4 is greater or equal to P and 7 is
Okay.
greater or equal to P?
Okay. No, it's fine. I got it. At first, I couldn't hear. So when something is written, for example, as 4, it doesn't matter whether it's less than, then we have P is less than 7. Or maybe it has, let's say that. So what I wanted to say, LB, is that this thing, it actually says P is between 4 and 7. P is between 4 and 7. But starting from 4 up to 7. So let me maybe try to explain something on a number line. If we have a number line, then we have 4 and 7. And we start saying we make that 0 there and we connect those two. So that means we are actually concentrating between 4 and 7. So this is how you write it. Let's say maybe whatever that is in between, we call it x. So we are going to say x is actually between 4 and 7. So because these circles are not shaded, that's why you just do that sign. But if these circles are shaded, then it means it's actually 4 less or equals to x less or equals to 7. So still the same thing. X is between 4 and a 7. So this equals to, it actually includes that 4 to say this x can still be 4, 5, 6, and it can still be 7. But with this one, it's more like x is between these two. So it starts at 5, then 6, and this 7 is not included. Just indicate if you understood, LB. If not, I'm going to explain again.
Oh, so you say that when it's shaded like that, it means that 4 and 7 is included. But if it's not, then it means that it's 5 and 6.
Yeah, so it's more like with this one, with a just circle, then that, then circle. It's more like, in short, yeah, this is more than, or maybe let me not use that as more than. Let me say we are talking about something which is between these two values, and these two values are not included. We are just talking about values in between. It could be starting from 4.1 up until maybe 6.9, but 7 is not included. But with this one, we start from 4, everything in between up to 7.
Okay, yes, it makes sense now.
Okay, so when I said the more than and whatever, so I wanted to say, if we say a G is greater than 4, and again, if we say G is greater than or equals to a 4, the difference between these two is that here we are saying maybe girls are greater than 4. So that means they are starting from 5 upwards. But if we say girls are greater or equals to 4, then that means they could be 4 going up. I'm not sure if it now makes sense, Albie.
So it says G is greater than 4, it's not G is less than 4.
Sorry, repeat that.
I'm saying that G is greater than 4 is represent less.
I think your line is breaking, Albie. Maybe unmute and try to say that again. I'm not getting exactly what you're saying. I hear you mentioned less than.
Wait, can you hear me now?
Yes, I can hear you now.
I was saying that you said G is greater than 4, and I'm asking, does that sign represent greater or does it not represent less?
Oh, this sign. You're asking if it,
Yes.
it if it doesn't. Okay, so this is how I cramped it, LB. Are you right-handed or are you left-handed?
I'm right-handed.
Do this. Do this. Can you see what I've done?
Yes, sir.
And also do the same using your left hand.
Yes.
So your right hand is like that, isn't it?
Yes, sir.
And your the shape of your left hand is like that, isn't it?
Yes, sir.
Between your left and your right hand, which one is greater in energy or has greater energy?
The right hand.
Which means this is greater than. What about this one? Obvious, isn't it?
Yes.
Then this is less than. So you can now do what you did. I hope you understand. So can you
And
now
they
see
said that
that
we said our teachers lying to us, like our primary teacher told us the crocodile the smaller number, huh?
No. He is lying. He is lying. You can just take a snapshot of this lesson and just play to him only when I'm saying he is lying, but never tell him what he's lying about. But he is lying, LB. But it should be a mistake that he made when he was explaining, or should I trust you, LB, to say, is it not you who's confusing these two?
Oh, sir, literally, it's like the crocodile's mouth that is open means that it's eating the less number.
That's completely incorrect. So just know it like that to
No,
say,
but I get it now, sir. The way you explained it makes sense.
so in grade 10, when I was in grade 10, I was confused by these things, I had to find a way to cram them. So that's how I cram them. Even up to date, I've never forgotten between which two, which one is greater, which one is less than. I just use my hands like that and remember this one is greater in energy and this one is less in energy. So after this lesson, just try to Google it. Then once you find out, you can just send me via inbox whether I'm correct or wrong. Nay.
Yes, sir.
Okay, 100%. So for now, just take it like that. So what I wanted to explain there, I wanted to say when they say the angle is between 0 degrees and 360 degrees, they are simply saying starting from 0. So that means this 0 is included. Nay. Then all the way up to 360 degrees, meaning also 360 degrees is included when we are dealing with um, this part which is extending ratios. But now, this is what I wanted to quickly show you. When we present angles greater than 90, obviously, it could be Agri LB. Initially, I've explained an angle which is less than 90, where we have a triangle falling under quadrant number 1. You remember, Mos?
Yes.
Yes, so this is a Cartesian plane. This is x and y. We have 90 there, 0 there, and we said this is 90-degree angle. So when you represent an angle which is greater than 90, that's what we mean when we say we are extending those angles. We are not only concentrating on angles which fall under quadrant number 1. We now extend these angles to other quadrants. So this is how you are going to represent an angle which is in that quadrant. So can you see the angle formed is from that 0 up to there. So this is the angle formed. So we say that obviously we know this is the y, this is r, and this is negative x. This is positive x, this is positive y, this is r. And again, if we want to extend this angle, we can also represent it in that quadrant. So we have a 90-degree angle there, we have negative y, still negative x, and that
So
angle is that one there. Mm-hmm.
wait, can you please explain? I remember you explained this before, like whether y or x is negative or positive in the first, second, third. Can you please explain that one more time?
Okay, so obviously this is the origin of a Cartesian plane. So from the origin towards the right, we have positive x values. From the origin towards the top, we have positive y values. From the origin going downwards, we have negative y values. So can you see we still have negative x values for this triangle? And again, if we extend the triangle there, what are we having? We still have negative y values, and again we have positive positive x values, which is the reason why we say in this quadrant all trigonometric ratios are positive, because whether you say positive r divided by positive that, get a positive ratio. That over that, you get a positive ratio. That over that, you get a positive ratio. But here, it's only x, which is what? Which is a negative, and x is on the adjacent side. That is the reason why we say cos is, wait.
That's
Let me
sine.
first confirm something. It
It's
has to be
cost.
sine,
The
eh?
cost diagram.
So it has to be sine there, ne?
Yes, sir.
So we focus on the positive values. So what makes it to be positive is because the ratio for sine is this positive y and positive r. That is why we say only sine is positive there. But did I answer your question where you said I should explain that one of the negatives and whatever?
Yeah, it makes sense now. Thank you.
Okay, so here obviously we say the ratio for that and that gives a positive answer. So here obviously it's only cos, which is a positive because of the positive x. So that means LB always R is positive. Always R is positive. Make sense?
Yes, sir.
So obviously this is a quadrant 2, quadrant 3, quadrant number 4. So I think for now, LB, let's leave it there. And the reason to that is because I notice I'm running out of battery. But what we have done up to this point is all that I wanted us to discuss as part of our introduction to this chapter. So the next part, that's where we'll focus on those reduction formulas and everything. So you say tomorrow we do more of a simplify and proving identities, ne?
Yes, sir. But mostly you can focus on like doing exam type questions, like question
Yes,
paper.
so we do exam question papers for those, ne?
Yes, sir.
Okay. Do you know my channel where I send question papers?
Yes, sir.
So it's fine. Even in
Wait,
that
your YouTube channel?
no, a Telegram channel. There's a Telegram channel where I post question papers for all the grades and all the subjects.
No, I don't know it.
Okay, I'll just send it in the group just now. Then when you get to that group, you'll find some old question papers of which you can browse through and just write down almost all the trig ratios that you think we can try to work on. I'll also get some more problems that we can also add on to that. Then from there, we'll continue. Remember to also send me those type of problems that you talked about, ne?
Yeah, yes, I have some few question papers I can just send you and we can practice with those ones.
Okay, all right. I mean for physics as well.
Yes, I have question papers as well.
Okay, 100%. LB, as you know, my name is Desmond, and I'm out. Complete it for
Thank
me.
you, sir.
The